Imagine waking up today and sensing that time itself feels different. The hours seem shorter, the daylight moves faster, and something about the rhythm of the day feels slightly out of place. At first, you might dismiss the feeling. Maybe you are tired. Maybe the clock is wrong. Maybe it's just another ordinary morning. But according to scientists monitoring Earth's rotation, that strange feeling may not be your imagination at all. As of March 15, 2026, data from multiple global observatories suggests something extraordinary has occurred. The standard 2-4-hour day that has defined life on Earth for millions of years may no longer exist. Atomic clocks across the planet devices, so precise they measure time to fractions of a second, began reporting an anomaly earlier today. Observatories from the United States Naval Observatory to the National Physical Laboratory in London all recorded the same result at nearly the same moment. At first, technicians assumed the systems had malfunctioned. After all, such a drastic deviation should be impossible. But as the data continued to arrive from independent networks, the conclusion became unavoidable. The Earth is spinning faster than it should, much faster. For billions of years, our planet has rotated with remarkable stability. The physics behind this stability is known as the conservation of angular momentum, a principle so fundamental that it governs everything from spinning tops to entire galaxies. In simple terms, once a massive object begins rotating, that rotation remains stable unless an enormous force acts upon it. A planet does not suddenly accelerate overnight. Changing the spin of a world requires an immense transfer of energy on an astronomical scale. Yet the measurements now show that something has done exactly that. The rotation period of Earth has shortened dramatically. Instead of completing one rotation in the familiar 24 hours, current models suggest the cycle has dropped closer to 20 hours. This is not a tiny adjustment like the leap seconds occasionally added to atomic clocks. This represents a massive physical acceleration of a planet weighing nearly 6 billion trillion tons. The amount of energy required to produce such a change is almost beyond comprehension. Scientists estimate that altering Earth's spin this quickly would require energy equivalent to detonating the entire global nuclear arsenal repeatedly every second for an entire year. And yet the satellite data shows no evidence of such an explosion. No catastrophic collision, no asteroid strike, no internal collapse of the planet's structure. Instead, attention has turned toward a mysterious object currently located roughly 150 million kilometers away from Earth. Astronomers refer to it as 3I Atlas. When telemetry from deep space monitoring systems was analyzed, researchers noticed something deeply unsettling. The gravitational interaction between this object and our planet appears to have changed, not slightly, dramatically. Multiple teams initially searched for errors in the data. They checked the sensors, recalibrated the instruments, and compared readings from separate space agencies. But every dataset returned the same result. The numbers were correct. Earth's rotation is accelerating, and the source of the torque appears to be this distant object. If that conclusion is accurate, the implications reach far beyond simply resetting our clocks. A faster rotation alters centrifugal forces across the planet. Ocean currents begin to shift. Atmospheric circulation changes. Even the structural stability of Earth's crust could be affected. And what is most troubling is that the acceleration does not appear to have stopped. The curve tracking the change is not leveling out. It is still rising, which leads to the question scientists everywhere are now asking: if the planet has already accelerated this much, what happens next? And the answer begins with something researchers discovered just 72 hours ago. To understand how we reached this moment, we have to rewind the timeline slightly The acceleration of Earth's rotation did not happen slowly over centuries or even years. It unfolded within the last 3 days. The first sign appeared on March 11, 2026, at exactly 14 UTC. At that moment, the International Earth Rotation and Reference System Service, known as the IERS in Paris, noticed something unusual in their monitoring data. Normally, Earth's rotation fluctuates slightly. Atmospheric winds, melting ice sheets, and ocean currents can cause variations measured in milliseconds. These tiny changes are so routine that scientists regularly adjust global timekeeping systems to compensate for them. But what the IERS detected that afternoon was not a millisecond shift, it was a 12-minute discrepancy. In astrophysics, a sudden 12-minute change in planetary rotation should only occur after a catastrophic event. A large asteroid impact could do it. A massive internal collapse might cause something similar. But there was no impact recorded anywhere on Earth. No shock waves, no seismic disturbances, no debris clouds visible in orbit. NASA's Goddard Space Flight Center immediately began recalibrating their instruments. At first, engineers assumed something had gone wrong with the sensors or that atomic clocks had somehow become unsynchronized. But then additional reports began arriving from independent observatories around the world. ESA's Swarm satellite constellation detected a subtle wobble in Earth's magnetic field. Radio telescopes in Australia cross-checked distant quasar positions and confirmed that the planet's rotational speed had indeed increased. 3 completely separate systems, using 3 completely different methods, all reached the same conclusion. The Earth was spinning faster. The timeline of acceleration then became impossible to ignore. By March 12th, the length of the day had shortened to approximately 23 hours. By March 13th, it had dropped further to around 21 hours and 30 minutes. And by the morning of March 14th, Earth had temporarily stabilized at a 20-hour day. The consequences of this change are already measurable. Centrifugal force at the equator has increased by nearly 18%. In regions close to the equator, places like Singapore or Ecuador, people technically weigh slightly less than they did only days ago. The oceans themselves are beginning to bulge outward due to the increased spin, producing unusual tide patterns that do not match any known lunar cycle. At this point, scientists began searching for a cause. Under natural conditions, a planet spins faster when its mass moves closer to its center. It is similar to a figure skater pulling their arms inward to spin more rapidly. But measurements show that Earth's size has not changed. The planet has not collapsed inward, and its diameter remains the same, which means something external must be applying torque. When astrophysicists mapped the gravitational influences around Earth, they looked first at the usual suspects. The Moon and the Sun were behaving exactly as expected. Their gravitational effects had not changed. But when researchers overlaid the trajectory of the object known as 3I Atlas, the correlation was astonishing. At the exact moment the IERS detected the first 12-minute rotational slip, 3I Atlas emitted a strange gravitational signal. Not a random disturbance, but a focused ripple in space-time itself, directed toward Earth's rotational axis. If the data is correct, this object did not collide with our planet. It simply pushed from across the vacuum of space, and the Earth responded. The idea that a distant object could influence the rotation of an entire planet sounds almost impossible. Yet, when scientists began calculating the energy required for the observed acceleration, the numbers became even more astonishing. To shorten Earth's rotation from a 24-hour cycle to a 20-hour cycle in just 72 hours requires an energy transfer greater than what the Sun releases in a full second. It exceeds the combined kinetic energy of every asteroid in the main belt. Under normal circumstances, injecting that much energy into a planet would generate enormous heat. The surface would warm dramatically. The oceans might boil in places. Yet measurements from satellites and ground-based instruments show something completely unexpected. Earth's temperature has not increased at all. This violates one of the most fundamental principles of physics. In every known energy transfer, from engines to exploding stars, heat is produced as a byproduct. Entropy increases, energy spreads. But in this case, the energy accelerating Earth's rotation appears to have been delivered with almost perfect efficiency. One theoretical explanation involves gravitational wave coupling. Instruments such as the LIGO detectors have observed gravitational waves passing through Earth before. These waves stretch and compress space slightly as they move, but they rarely transfer significant rotational energy. What makes the signal associated with 3I Atlas unusual is that it appears to form a standing gravitational wave, a coherent beam that locks onto Earth's mass distribution. An easier way to visualize this is to imagine two magnets. If one magnet begins spinning, the other can start spinning as well, without direct contact due to magnetic coupling. In this case, scientists believe something similar may be happening with gravity itself. The rotation of 3I Atlas could be forcing Earth to synchronize with its own rotational motion. If that interpretation is correct, the consequences extend far beyond timekeeping. Earth is not a solid sphere. Beneath the thin crust lies a molten outer core of liquid iron surrounding a solid inner core. When the crust accelerates rapidly, the liquid beneath it cannot keep up immediately. This creates friction along the boundary between the mantle and the core, and friction at that scale produces powerful electromagnetic effects. Just hours ago, NASA's magnetospheric multiscale mission recorded a sudden spike in Earth's magnetic field strength, an increase of roughly 12%. A stronger magnetic field might sound beneficial because it shields our planet from solar radiation, but rapid fluctuations in that field can induce electrical currents across long conductors such as power lines, pipelines, and undersea communication cables. Already, engineers are reporting strange voltage fluctuations across sections of the global electrical grid. But the data reveals something even stranger. The acceleration of Earth's rotation is not perfectly uniform. Measurements suggest the northern hemisphere is rotating slightly faster than the southern hemisphere. For a rigid body like a planet, that should be physically impossible. The only explanation is that the crust itself may be twisting under the stress. Normally, forces of this magnitude would trigger earthquakes along nearly every major fault line. Yet seismic networks report something unexpected. The tectonic plates are not breaking apart. Instead, they appear to be stabilized by the same external gravitational influence that is accelerating the rotation. In other words, the force speeding up Earth may also be holding the planet together. And if that level of control is real, then the object responsible 3I Atlas may not be a comet or asteroid at all. It may represent a level of technology far beyond anything humanity currently understands. If the interpretation scientists are now considering is correct, then what we are witnessing may not simply be a natural cosmic event. It could represent a level of control over gravity that humanity has never observed before. In astrophysics, there is a framework called the Kardashev scale, which classifies civilizations based on the amount of energy they can control. A Type 1 civilization harnesses the energy of its entire planet. A Type 2 civilization commands the energy output of a star. The capability required to remotely alter the rotation of a planet from 150 million kilometers away without destroying it would fall somewhere near that second category. Pause for a moment and consider what that means. For 4 billion years, Earth has followed the same rotational rhythm. Life evolved under that rhythm. Our biology, our ecosystems, even the migration patterns of animals depend on the 24-hour circadian cycle. But now that rhythm has shifted to 20 hours, and the change happened in less than 3 days. Biologists are already warning that this sudden shift could affect everything from plant growth cycles to human sleep patterns. Our internal clocks are deeply synchronized with daylight and darkness. A shorter day could create global disruptions in biological processes that have taken millions of years to stabilize. But the physical effects extend far beyond biology. When a planet spins faster, the Coriolis effect becomes stronger. This is the force responsible for shaping large-scale weather systems on Earth. Hurricanes, jet streams, and ocean currents all depend on it. With the planet rotating more quickly, those systems may begin to behave differently. Climate models are already being updated to simulate what a permanent 20-hour day might look like. Preliminary predictions suggest stronger storms, faster atmospheric circulation, and significant shifts in global climate patterns. In simple terms, the planet's entire environmental balance could begin to change. Yet another mystery remains. If Earth suddenly sped up this dramatically, the atmosphere should have lagged behind the solid surface. That lag would produce winds of extraordinary speed, possibly hundreds of miles per hour at the equator. Such winds would be easily detectable by weather stations across the globe, but that is not what meteorologists are observing. Wind speeds remain within normal ranges, which means the atmosphere has accelerated along with the planet. The air itself appears to be rotating faster in perfect synchronization with the crust beneath it. For this to happen, whatever force is acting on Earth must not be gripping only the planet's solid mass. It must also be affecting the gas surrounding it. In other words, the entire Earth system, rock, ocean, and atmosphere is being accelerated together as a single unit. That level of precision suggests something even more unsettling. The acceleration curve is not chaotic. It is mathematically smooth, following a predictable progression. When researchers projected the curve forward, they noticed something disturbing. If the trend continues at the current rate, the planet could reach an 18-hour day within the next 48 hours. And if the rotation reaches 16 hours, the consequences will extend beyond weather or biology. At that point, many of the satellites orbiting Earth could begin to drift out of position. Satellites orbit Earth according to extremely precise timing. Geostationary satellites, which provide much of our communication and weather monitoring systems, rely on the fact that Earth rotates once every 24 hours. Their orbit matches that rotation, so they remain fixed above the same point on the planet's surface. But if Earth's rotation continues accelerating, that balance will break. At a 16-hour day, many satellites would no longer stay aligned with their ground positions. GPS networks could begin losing accuracy. Weather monitoring systems might drift away from their designated coverage zones. Communication networks that rely on satellite relays could experience widespread disruption. Yet even those technological consequences may not be the most serious danger. The real threat lies in the increasing centrifugal force generated by the faster rotation. As Earth spins more quickly, that outward force becomes stronger, especially near the equator. Gravity would effectively weaken in those regions. When that happens, the oceans respond. Water naturally moves toward areas where centrifugal force is greatest. With a faster rotation, enormous volumes of ocean water could begin migrating toward the equator. Coastal cities near equatorial regions might experience flooding not because sea levels are rising slowly from climate change, but because the water itself is bulging outward due to the planet's spin. Entire shorelines could be reshaped. But just as scientists began modeling these possibilities, a new discovery changed the situation again. Earlier today, at 11:42 UTC, the European Space Agency's Gaia spacecraft detected something that no one expected to see. Earth's rotational axis has shifted. Normally, Earth is tilted at approximately 23.5 degrees relative to its orbit around the Sun. This tilt is what produces our seasons. Over very long timescales, tens of thousands of years, the angle can change slightly due to gravitational interactions with the Moon and other planets. But Gaia's measurements indicate that Earth's axis has moved by 0.08 degrees in just 6 hours. That may sound small, but in planetary mechanics, it is enormous. A shift of that magnitude would normally require a collision with an object the size of a moon. Yet no such collision occurred. Instead, the axis appears to be moving in a very specific direction toward the constellation Cygnus. Even more strangely, that direction aligns closely with Cygnus X1, one of the most well-known black hole systems in our galaxy. Scientists cannot yet explain this alignment. If the shift continues, the consequences for Earth's climate could be severe. Seasonal patterns would change dramatically. Some regions might receive far more sunlight than they do today, while others could remain in extended darkness. Climate models suggest that if the tilt continues moving at this pace, major environmental disruption could occur within weeks rather than centuries. Within hours of this discovery, emergency meetings were convened among international space agencies. Even the United Nations Security Council reportedly held a closed session to discuss the implications, because if the axis is truly being redirected, then Earth is not just spinning faster, it is being aimed. At this point, several facts are no longer disputed among scientists studying the data. First, Earth rotation has accelerated to roughly a 20-hour day. Second, the centrifugal forces produced by that acceleration are increasing. Third, the crust of the planet appears to be stabilized by an external gravitational influence, preventing catastrophic tectonic activity. And fourth, Earth's rotational axis has begun shifting with unusual precision toward a specific region of space. All available observations point toward the same mysterious object, 3I Atlas. Telescopes across the world are now tracking it continuously. Every major space agency has redirected instruments to monitor its behavior. Yet, despite this unprecedented attention, the purpose behind these changes remains unknown. One of the most unsettling questions scientists are asking is deceptively simple. Why exactly 20 hours? If this phenomenon were purely natural, we would expect chaotic changes, irregular shifts caused by unpredictable gravitational interactions. But the acceleration curve is smooth and controlled. It appears to be approaching a target rotation speed. And when researchers compared that speed to the rotation of 3I Atlas itself, they discovered something remarkable. The object completes one full rotation every 20 hours. If that measurement is correct, then Earth is being synchronized with it. That raises two possibilities. The first is that this is some unknown natural resonance effect, an interaction between two rotating bodies producing gravitational coupling on a scale never previously observed. The second possibility is far more unsettling. 3I Atlas may be intentionally altering the rotational state of our planet. Why would any object or intelligence do such a thing? One explanation scientists have cautiously discussed involves environmental transformation. A faster rotation strengthens atmospheric circulation and increases planetary energy levels. In theory, altering a planet's rotation could gradually reshape its climate and magnetic environment. In other words, the process might resemble a form of planetary engineering, terraforming, but there is another possibility as well. The rotation of Earth might not be changing for Earth's benefit at all. Instead, the planet could simply be matching the rotational frequency of the object influencing it. Synchronization. As you watch this, the data stream from satellites and observatories continues updating in real time. The day has already shortened. The nights are arriving sooner than expected. Ocean levels near the equator are slowly shifting, and the rotational axis continues its subtle movement across the sky. Within the next 12 hours, scientists expect one of two outcomes. Either Earth's rotation stabilizes at this new 20-hour cycle, or the acceleration continues, pushing the planet toward even shorter days. If that happens, the centrifugal forces could eventually begin pulling the atmosphere outward into space. For now, every telescope remains pointed toward 3I Atlas. Every gravitational detector is active. Researchers across the world are watching the same data feed, waiting for the next change, because whatever is happening to our planet right now, it is still unfolding. And if you want to stay updated as new discoveries emerge about this mysterious object and the future of our planet, make sure you like the video, share it with others who love space and science, and subscribe to the channel so you don't miss the next update.